kind of want to look at a couple more equations of graphing that are a little interesting. You've seen them before in grade 9, hopefully, but definitely want to take a look at again. Just make sure that we kind of brush off the dust on them. These two equations are the equation of a horizontal line, and a vertical line. Now, both of these are considered linear relations. However, only one of them is considered a linear function. A horizontal line will always have the form of y equals, and I'm going to name it some constant a. So something like y equals 1, y equals 3, y equals negative pi. Who knows, right? These are all considered horizontal lines, since the only thing that the equation tells us is the y-coordinate. It has absolutely no dependency on x. Even though y is a dependent variable, the equation that they state, 1, 3, or negative pi, is completely independent of x. So if you wanted to make a very quick table here, what would fill on this side is all of your values of a. So 3, 3, 3, if I was using 3. And like I said before, hey, give yourself a couple of different x values, negative 2, 0, 2. Well, it wouldn't matter where I'm going in terms of x. I would always have a horizontal line that goes across 1, 2, 3, 1, 2, 1, 2, x, y, that goes across the y is equal to 3 line. So that's a horizontal line. It's a linear relation, but actually it is a linear function as well, as it will pass the vertical line test. There is no double entry of domain. There is no repeated entry of domain. So this is actually a function as well. The other one that I want to take a look at is a vertical line, and it's basically opposite of horizontal line. No kidding. So a horizontal or a vertical line has the function, or not the function, has the equation, x equals some constant a. So just like before, it could be like an x equals 1, an x equals 3, or an x equals, I don't know, negative root 2. Who knows? Who cares really what it is? But it's saying that all of these equations are only x, or only are independent variable. And even though we can have a dependent variable that depends on x, it's not listed in this equation. So if we were to have x and y, you are no longer allowed to give out values of x. It has to be the one that's in the equation. So like negative root 2, negative root 2, negative root 2. And it wouldn't matter what you have for y. 1, negative 5, 7. I don't know. I just made up a bunch of values. All of these coordinates have negative root 2 in common with each other. So they would all have, let's go with 1, let's go with 5. I'm doing poor graphing techniques. I know you guys will forgive me. But they would all be at this line that goes across, up and down, and this would be y is equal to negative root 2. Approximately 1.41 or something like that. Negative, of course. And that's a vertical line. This is not a function because we have repeated domain values. Not a function. We have repeated domain values, so we cannot be a function. It is a relation. It's a linear relation. Both of these are linear relations, but only one of them is a linear function, and that is a horizontal line.